Hello everyone. Today let us discuss about projectile motion. Projectile motion. So let's start our discussion. Projectile motion, what does it mean? Projectile. First of all, let us see what is a projectile. Projectile, it is a body thrown into space and allowed to fall freely under gravity. Anything which is thrown out into the space and allowed to fall freely under gravity. Example, a javelin thrown by an athlete. Like example, Neeraj Chopra thrown a javelin and got gold medal for India. That is a projectile motion. Another example is a cricket ball or a football. It goes in a projectile motion. A third example, you can think about a shot put thrown by an athlete. Now, let us see the motion of a projectile. The motion of a projectile may be thought of as the result of two separate, simultaneously occurring components of motions. That means two types of motions will take place here. Example, if you take like this is a projectile motion. One way it is going front, another way it is going up. That means horizontally it is moving forward and vertically it is moving upward. That means it is a combination of two motions. One is a horizontal motion, another is a vertical motion. Now, if you think about the horizontal motion, in the horizontal direction, the projectile goes without any acceleration. But in the vertical direction, it has acceleration. That is nothing but acceleration due to gravity. Acceleration due to gravity. So in simple words, if I can tell you, if you have thrown something, a cricket ball or a javelin, it goes like this. That means along x-axis it has come forward. Along y-axis it has moved upward. In this case, this is the starting velocity u and the angle which it makes with the x-axis is theta. That's called as angle of projection. In this horizontal motion means along x-axis, it doesn't have acceleration. But in the vertical direction, that is along y-axis, it has acceleration due to gravity. So now we have to study projectile motion with respect to these two types of motions, horizontal and vertical. Now, let us consider a body projected from the point O. You can see here it is projected from this origin O. And let its initial velocity be u. Starting its velocity is u. And let theta be the angle of projection. This angle is theta. That angle is theta. Now, u, that is the starting velocity is u. Here I have shown it here. Then this u can be resolved into two components. Along x-axis, u cos theta, and along y-axis, u sin theta. So you can resolve it into two components, u cos theta and u sin theta. Therefore, horizontal motion of the projectile is uniform motion. The horizontal component of the horizontal component of the velocity does not change with time. Note this important point. This horizontal velocity does not, that is u cos theta, does not change with time. Therefore, horizontal motion of the projectile is uniform motion, or it doesn't have change. It doesn't change. Therefore, horizontal motion is a uniform motion. But vertical component of velocity changes with time. Vertical component of velocity changes with time. Therefore, vertical motion of the projectile is accelerated motion. That means upward motion is accelerated. Accelerated motion. Because gravity is working in the downward direction, that is vertical direction. The vertical component of velocity changes. Why vertical component changes? Why horizontal does not change means vertical, in the vertical direction, that is gravity is working. Therefore, vertical component of the velocity changes and it becomes 0 at the maximum height. This is the point. This is the maximum point. This is the point at maximum height. Let A be the point where it reaches the maximum height. At that point, the it becomes 0. Vertical component of the velocity becomes 0. The acceleration in the vertical direction is equal to acceleration due to gravity. That is nothing but g. After its velocity becomes 0, the projectile changes its direction and moves downwards. At this point, what happened at the point A? Its vertical component of velocity u sine theta has become 0. Then what it will do? Instead of going up like this, it starts falling down like this. It starts falling down because its velocity has become 0 at that particular point. Now, as it moves downwards, it moves with the increasing value of vertical component of velocity. As it moves downwards, it moves with increasing value of vertical component of velocity. Now, we have 4 derivations in this particular topic. Here we have to derive 4 derivations. The first one is we have to show that the path of the projectile is a parabola. Parabola means its shape is like this. We have to show this is a parabola. So we have to show that the path traced by the projectile is a parabola. So now let's start first derivation. Later we will see 3 more derivations, that is for the height of the projectile, for the range of the projectile. Height means this is the maximum height. Range means the longest distance which it can travel in the horizontal direction, and the time of flight. That means the time taken for the projectile. 3 more derivations we will do. First let us prove the path traced by the projectile is a parabola. So you can see in this picture, O is the point of projection. Here we have O is the point of projection. U is the velocity. So this is the U, initial velocity of the projectile. Then theta is the angle of projection. So you can see like this it is. This is U and this is theta. This is origin. Theta is the angle of projection. H is the maximum height reached by the projectile. This is the maximum height reached by the projectile. R is the range of the projectile. This is the range of the green color one, is the range of the projectile. Then capital T is the time taken for the projectile, that's called as time of flight. U cos theta is the horizontal component of U, that is in this direction, and U sin theta is the vertical component of U. And y is the vertical distance covered by the projectile in time t. So let us take in between a point. Let us take in between a point where the vertical, that is vertical distance covered by the body in time t is y. Let us take like that. Then, after that, let us show that the path traced by the projectile is a parabola. Now, for horizontal uniform motion, that means along x-axis, because it is uniform motion, our fundamental equation v velocity is equal to distance by time. We will apply that. Velocity means horizontal direction, it is u cos theta. Displacement along x direction in a time t is x, and the time taken is t. And the time taken is t. In a small time t, let us assume the projectile has reached this point A. Let us assume it has reached the point A. At that particular point, vertical displacement is y and the horizontal displacement is x. Vertical displacement is y, horizontal displacement is x. This is the horizontal displacement. Now, the horizontal motion is uniform motion. Therefore, uniform motion, we can apply our fundamental equation v is equal to d by t, distance by time. V means u cos theta along x-axis, distance is x and time t, where x is the horizontal distance covered by the projectile in time t. Therefore, from this equation, t is equal to x by u cos theta. From here, t is equal to x by u cos theta. So, let us start our derivation with this. That is, equation 1 is x u cos theta is equal to x by t. From that, t is equal to x by u cos theta. Now, in the time t, let y be the vertical distance covered by the body. Then, here it moves upwards. That means, in a time t, it covers this distance y, the distance y. Now, it is accelerated motion because acceleration due to gravity is working in the vertical direction. Then, we have to apply this formula. S is equal to ut plus half at square, S is equal to ut plus half at square. But for vertical motion, upward motion, a is equal to minus g. Therefore, S is equal to ut minus half gt square. So, taking that into consideration, S means h height, which is y in this case. Vertical u means velocity. Velocity is uy in this case. T is the time taken minus half gt square. Now, after that, y is equal to uyt minus half gt square. Uy means u sin theta. Uy is equal to vertical component u sin theta, which is u sin theta. So, in place of uy, we have substituted u sin theta t minus half gt square. This is for the upward motion, g is negative. Therefore, let us substitute equation 2 in 4. 2 means this one, this is this one. T is equal to x by u cos theta. Let us substitute in equation 4. In place of t, we will substitute x by u cos theta. In place of t square, x by u cos theta whole square. Then it becomes y is equal to u sin theta x by u cos theta minus half g x by u cos theta whole square. Then sin theta by cos theta is tan theta, and u cancel. Sin theta by cos theta is tan theta into x minus g by 2 u square cos square theta, because u cos theta whole square into x square. Then, after taking that, let it be equation number 5. Now let us take tan theta as small a and g by 2u square cos square theta as b, then substitute tan theta as a and g by 2u square cos square theta as b, then we will get this equation y is equal to ax minus bx square. This is nothing but the equation of a parabola. This is the equation of a parabola. Therefore, what we have proved finally, we have proved that the path taken by the projectile is a parabola. Hope you understood this. Let's move on. Let's go for the next derivation, that is the time of flight. Time of flight means the time taken for the projectile for the full journey. That's called as time of flight. Time of flight. That means from origin it goes like this and it goes falls at C. So the time taken for that to travel from O to C, that's called as the time of flight. Now let us take the vertical motion. It is an accelerated motion. So v is equal to u plus gt is our formula. But for the upward motion, we take g as negative. Therefore, it becomes v is equal to u minus gt. Therefore, upward motion vy, we are taking subscript. Vy is equal to uy minus gt. At the point of projection, initial velocity uy is equal to u sin theta. Here we have shown it. At the time of projection, initial velocity uy is equal to u sin theta. Therefore, at the highest point, you can see here vy is equal to 0, final velocity is equal to 0. Substitute initial velocity as u sin theta, final velocity as 0. We will get, in place of vy we got 0, in place of uy we got u sin theta, and we got this equation, u 0 is equal to u sin theta minus gt. So let it be equation number 2. But b is only half of the full motion. Up to here it is half motion. From here to here again another half motion. Therefore, O to B, it is only half of the motion. Therefore, the time taken up to B is half of the projectile's time of flight, that is t by 2. Therefore, substitute t by 2 in this equation. 0 is equal to u sin theta minus g by 2. Bring g by 2 this side. Negative will become positive. Gt by 2 is equal to u sin theta. Therefore, t is equal to 2u sin theta by g. 2u sin theta by g. This is the derivation for the time of flight. T is equal to 2u sin theta by g. It's very simple, no? Where t is the time of flight. That is the total time taken for the projectile motion. Simple. The first kinematic equation we have applied here. V is equal to u minus gt. At the highest position, v is equal to 0. Initial velocity is u sin theta. Substituted in that simple first kinematic equation, in place of v0, in place of u sin theta, minus g t by 2, because up to this only half of the journey, so t by 2 we have taken, and then simplifying it, g by 2 we brought to the left side. So gt by 2 we brought to the left side. Therefore, t is equal to 2u sin theta by g. Let's move forward. Let's derive the expression for the maximum height. So in this picture, B is the point where it reached the maximum height. Therefore, h is the maximum height. From here to here, it is h. That is h. So let us take h. It is the maximum vertical distance travelled by the projectile. What is h? It is the maximum vertical distance travelled by the projectile from the point of projection. In y direction, this is the maximum height. For upward motion, g is negative. I told you already. Then upward motion, we can take the equation h is equal to v minus ut. H is equal to v minus ut. Then v square minus u square is equal to minus 2gh. Minus 2gh. Then let us take vertical motion, vy square minus uy square is equal to minus 2gh. Minus 2gh. So let us take u vy square, that is v square minus u square is equal to 2as formula we have taken, third kinematic equation, and we have substituted. There we get vy square is equal to uy square minus 2gh. Let it be equation number 1. Let it be equation number 1. Now coming to the point, initial velocity is u sin theta and final velocity is 0. Already we talked for the time of projectile. Time of projectile we have taken, and that is v uy, that is initial velocity is u sin theta. vy is equal to 0. Substitute in the kinematic equation, v square minus u square is equal to minus 2gh. v means 0, minus u square sin square theta is equal to minus 2gh. This is what we got. Then 2gh is equal to u square sin square theta. Therefore h is equal to u square sin square theta by 2g. This is our derivation. Simple, very simple. And so that's what we are doing here. What we are doing is we have taken the third kinematic equation. Third kinematic equation. What is the third kinematic equation? We have taken the third kinematic equation, that is v square minus u square is equal to 2as. In that v we substituted 0, u is u sin theta, and taken s as h, g is minus g, and substituted. Then u square sin square theta minus 2gh is equal to 0, or 2gh is equal to u square sin square theta. Therefore h is equal to u square sin square theta by 2g. So this is our derivation for maximum height of a projectile. Maximum height of a projectile. Next, let us move on to the last derivation. Horizontal range of projectile. Horizontal range of projectile, that is from here to here, O to C, that is called as horizontal range of projectile. Horizontal range of projectile. So here you can see from origin to the point C, it is the maximum distance it travelled. That's called as the horizontal distance. Horizontal distance. There is no change in velocity in the horizontal direction. The important point from the beginning I have been telling is there is no change in the velocity in the horizontal direction. It is a uniform motion. It is a uniform motion. In the uniform motion, we can use our very basic equation, that is fundamental equation. Velocity is equal to displacement by time. Displacement by time. Then velocity means horizontal direction, it is u cos theta, and displacement is r. Time is the time taken for the projectile is capital T. So this is what we got. We substituted here. So what we got now is ux is equal to u cos theta is equal to r by t. Velocity is equal to distance by time. Therefore, cross multiplication. So we will get r is equal to u cos theta into t, or t is equal to 2u sine theta by g. So which we got earlier. This is what we got earlier. T is equal to 2u sine theta by g. 2u sine theta by g. So this is what we have substituted there in this equation t. That is t is equal to 2u sine theta by g. That is from the previous derivation, which we have taken and substituted here. We have substituted here, and we got now r is equal to, from here we got r is equal to u cos theta. T means 2u sine theta by g. 2u sine theta by g. Therefore, it will become r is equal to u square, u into u square, 2, here we have 2 sine theta cos theta divided by g. So what we got now? U square 2 sine theta cos theta by g. But according to trigonometry, 2u sine theta cos theta is equal to sine 2 theta. 2 sine theta cos theta is equal to sine 2 theta. Therefore, r is equal to u square sine 2 theta by g. Therefore, r is equal to, that is range is equal to u square sine 2 theta by g. This is the last derivation. Finally, we have derived 4 equations today. First thing, we have shown that the motion of a projectile is a parabola. Second, this is the first one which we have proved. The motion of a projectile is a parabola. Second, we have proved that the time of flight, which is t is equal to 2u sine theta by g. Next, we have taken maximum height, that is h is equal to u square sine square theta by 2g. That is what? And the last one is range, r is equal to u square sine 2 theta by g. With this, we have completed all our derivations. Thank you for watching this video. Before closing, I just want to tell you some important points for competitive exams. When sine 2 theta is equal to 90, that means theta is equal to 45 degrees, range is maximum. Please note these points for competitive exams. When sine 2 theta is equal to 90, that means 2 theta is equal to 90, theta is 45, range is maximum. For an angle of projection of 45, range is maximum. Next point, for complementary angles whose sum is 90 degrees, for a given velocity, range is same. For example, if you throw with 30 degrees and 60 degrees, for both of these degrees, angle of projection of 30 and 60, that range is same. Range is same. Please note these points. Now, to get maximum height, theta should be 90 degrees. Third point. To get maximum height, theta should be 90 degrees. Fourth one. For maximum range, maximum height will be r by 4. So this is our maximum height and this is the maximum range. If you want to get a maximum range, that is when theta is 45, in that particular case, height will be equal to r by 4, that is range divided by 4. Note these points for the competitive exams. The last point, the time of flight and maximum height depend on the vertical component of velocity. We know that time of flight and maximum height, they both have sine theta in their equations. This is height. You can see sine theta here. Okay. Then time of flight, here also you can see sine theta. In both these things, we have sine theta component. So therefore, they depend upon vertical component of velocity. Thank you for watching this video. Let us meet with another video. Until then, bye. God bless you all.